So this was a pop quiz related to alcohols and halogen alkanes. Ammonia react with chlorobutane. State the type of a mechanism. Whenever there's a reaction between ammonia and chlorobutane, the type of a reaction is known as a nucleophilic substitution. Look, type of a reaction is nucleophilic and mechanism is substitution. So it is nucleophilic. The nucleophilic substitution reaction. Mechanism is substitution and the type is nucleophilic. Student drew first step of the mechanism identified two emissions in student mechanisms. The student's mechanism. So what are the two emissions? First thing, student did not draw the lone pairs. Like there should be lone pairs here on the nitrogen. That student missed. And another thing, here is partial negative, so carbon is partial positive. These are the two emissions. So the two things which student missed, the lone pair of the nitrogen and the partial positive charge of the carbon. To obtain butylamine, sodium hydroxide solution is added. Complete the next step of a mechanism to form butylamine. Show curly arrows and relative lone pair and the reaction product. So this is the first step as ammonia attack on the positive center and chlorine leave, and then we have to produce a butylamine from this. Butylamine means like 4 carbon atoms will be there and then NH2 group will be there, which will be the amine. So student add sodium hydroxide means student added hydroxide, OH. This OH, which is having a lone pair, so this will be attracted or hydrogen will be attracted, but we draw the arrows from lone pair. So this will attack on the hydrogen and the nitrogen will take, because it's a positive charge on nitrogen, so it will take both of the electron and it will become neutral. So the bond will break between them and we have H, CH2 is there, CH2 is there, CH2 and NH, and then OH and H will combine with each other, H plus and OH. This was having a negative charge because from hydroxide, so it will become OH minus and H plus, so it will produce H2O. So this will be the structure of water molecule. The next is the reactions of ammonia and hydroxide ions with halogen are similar. Compare the rate of reaction of ammonia with 1-chloro with 2-bromo 2-methyl propane. Justify your answer. So first thing, if we have 1-chlorobutane, like if you are having CH2, CH3, CH2, 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 Cl, and we have 2-methyl propane, 2-bromo, like second position bromine is there, second position methyl is there, and propane. This is what, when a carbon is attached with a halogen, there is one carbon chain. So this is a primary. Here halogen is attached to a carbon and this is surrounded by 3 carbon chains. So this is tertiary. So first thing, we compare the type. We will say like 1-chlorobutane is a primary and 2-bromo 2-methyl. This was 1-chlorobutane was primary, but 2-bromo 2-methyl propane is a tertiary. So if it is a tertiary, what will happen when we compare their mechanism? Both will undergo SN reaction. This will be SN2 reaction and this will be SN1 reaction. But here, the second thing what we have to compare the rate of a reaction in terms of the bond strength, we have to compare because different halogens are attached here. So which halogen is attached here? This is a chlorine is attached, and here bromine is attached. And what about the bond enthalpy? Like carbon fluorine bond is much stronger than carbon carbon fluorine bond is much stronger than carbon chlorine. Carbon chlorine is stronger than carbon bromine, and carbon bromine is stronger than carbon iodine. So the bond strength or bond enthalpy decreases as we go down. So which bond can break down easily? The carbon bromine can break down easily as compared to carbon chlorine. So carbon chlorine bond need more energy as compared to carbon bromine. So if this need less energy, small amount of energy, the bond will break down quickly. So the rate of the reaction for this one will be faster, and the rate of the reaction for this one will be slower. Is it clear? So rate of a reaction for 1-chlorobutane is slower because the bond enthalpy of carbon chlorine is higher as compared to carbon bromine. And you will mention, list the type, which one is a primary and which one is tertiary. Is it clear, part C? So this was a pop quiz 4.